purpose of this mini lecture is to look at the relationship between atoms, molecules, formulas, and numbers. Let's suppose that we have a sample of ethane gas which consists of 0.250 moles of that substance, which has the formula C2H6. Now, the formula tells us that each molecule contains 2 carbon atoms and 6 hydrogen atoms. So that will eventually allow us to determine how many carbon atoms and how many hydrogen atoms are present in the sample. But we need to begin by recognizing the relationship between numbers and moles. 1 mole of C2H6 contains Avogadro's number that you see here, 6.02 times 10 to the 23rd molecules of that substance. Now, if we have 0.25 moles, then 0.25 moles will contain 0.25 moles of C2H6 times Avogadro's number, 6.02 times 10 to the 23rd C2H6 molecules per mole, and that will give us 1.51 to 3 significant figures times 10 to the 23rd C2H6 molecules. Now, to determine the number of carbon atoms, we'll start with this number of molecules of C2H6, and if we recognize in the formula that there are 2 carbon atoms for each of those molecules, and if we multiply the number of molecules times 2 carbon atoms per molecule, the molecule units will cancel, and we'll get 3.01 times 10 to the 23rd carbon atoms. As practice, why don't you calculate how many hydrogen atoms will be present in the same sample? So to review, 0.25 moles of C2H6 contain 1.51 times 10 to the 23rd C2H6 molecules using Avogadro's number, and 3.01 times 10 to the 23rd carbon atoms by taking advantage of the formula. The relationships that we see here are good for any molecules or compounds for which we know the formula.